So we'll just fast forward this one as well. Now the question is, what is the resolution of vector, or what do we mean by resolving the vectors, and why do we resolve vectors to begin with? Now first of all, resolution of vector or resolving the vector means splitting the vectors into their components. So we say, okay, we have a single vector. It can be thought to be made up of smaller components. And if you add all of them, you get the same vector. Those smaller parts of the vectors are called components. How many components can be there for a vector? The answer is as many as we want. But in our calculation, whenever we draw the components of vectors, we draw only two components in such a way that the two components will be perpendicular to each other. So if one of the components to the right, the other one could be upwards. So two vectors can be represented by a single vector that has the same effect. The two vectors would then be called as components of the vector. Example. So forget about the axis, just take a look at the red vector, which is a vector of force. And it's making an angle theta with x-axis, with horizontal. Now the question could be, how much of the force or how much of the effect of the force would be towards x-axis, and how much of the effect of this force would be towards y-axis? In order to answer that question, we have to resolve this vector into components. So one of the component would be towards x-axis, and one of the component of the vector 2 would be towards y-axis. So mathematically, we can represent by this thing. So you see fx over here, this is a vector along x-axis, this is a vector along y-axis. Now think about it, this thing, we have a right angle triangle. For that right angle triangle, this is the hypotenuse, this is the base, and this is the perpendicular, this is the angle theta. If I take sine theta, that would be perpendicular over hypotenuse. So sine theta would be equal to Fy over F. Sine theta equals to Fy over F. And if you shift F on the other side, you get Fy equals to F sine theta. Likewise, if you use cos theta, then cos theta would equal to Fx over F. And if you rearrange it for Fx, you get the expression Fx equals to F cos theta. And you can also make a function of expression for tan theta. So tan theta would be perpendicular over base. So tan theta would equal to Fy over Fx. Let's say the magnitude of the vector F is given as 10 Newton. And you're also provided with the angle, which in this case was 40 degrees. If you're provided with the vector, magnitude of the vector, let's say given as 10, and you're also provided with the angle, can you find the components of the vectors? Yes, we can. How do we find? By using those expressions, by using those formula. If we want to find the x component, we can use the expression cos theta, which eventually gives us this one, Fx equals to F cos theta. So if we simply want to find the x component, multiply the vector by cos of the angle, cosine of the angle. If you want to find the component y, multiply the magnitude of the vector with the sine of the angle theta. But the question is, what if you're provided with the components of the vectors? Can we find the vector itself? So we're not provided with this thing, 10. We don't know. And we are not even provided with the angle. However, we are provided with fx and we are also provided with f5. We can find it out by using the Pythagoras theorem. So in simple words, this is your hypotenuse, this is your base. Base is given because the value of fx is given, so base is given, and the value of fy is also given. So you see this one is just parallel to this thing, so this is also your fy. Fx is given, fy is given, and thereby you can simply find the value of f using Pythagoras theorem. And what is that equal to? You can say, if I write the simplest expression, the square of the hypotenuse in this case equals to the square of the base plus the square of the perpendicular, and then you can take square root on both sides and you'll be left with this thing, fx square plus fy square, and then square root of it, something like this. So let's say you have found the magnitude. They asked you to find the vector. If they ask you to find the vector, it means not only you need to find the magnitude, you gotta find the direction as well. So you need to find this angle theta. Let's say they asked you to find the angle of the vector with x-axis. So how do you find this angle? Well, once you have found the magnitude, you can use any of the trigonometric ratio to find this angle. For example, if you use sine theta, then sine theta equals to perpendicular. Perpendicular in this case, the opposite to this angle would be fy over hypotenuse. Hypotenuse is f. But what I recommend is, because this is the value that you found using your calculations, so instead of using this value, it's better to use the value that you did not calculate, rather the value that was given in the question already. So what if we make use of fy and fx? So basically what I'm saying is we can use perpendicular and base, because hypotenuse is the one that we calculated, and if we do some mistake in that, the mistake would be carried forward. Although you are credited for carry forward, the marks are always carried forward in these kind of scenarios, but it's just a good practice to use the values that are given in the question already. So which trigonometric ratio can I use? Tan theta, right? So tan theta equals to perpendicular over base. I don't even need hypotenuse for that. So theta, you find the ratio of it, or you can just hit it on the calculator directly, this one, and then insert the fraction button, then put the values in the fraction, hit the magic button, which is the answer button on the calculator. You'll be getting your answer. Alright, so the next thing is, what if you're provided with one of the component, let's say fx is given, which is 3 Newton. Alright, let's suppose, and the angle is also given. Let's go with a little bit different. The angle is also given. The question is, if one of the component of the vector is given and the angle with respect to x component, the angle with respect to x-axis is also given, can you then find the vector itself? Can you find the vector f, and what expression can be used? Or do we need to find something else before we could find f? So one of the component of the vector is given, x component of the vector is given. We need to find the overall vector. any mathematical expression that can be used, or do we need to find something else first before we could find the value of f? Were you saying something? You were not audible. Okay, so you're saying we need to find fy first, right? Okay, so this is one of the method. If you want to go with that method, perfectly all right. But what if we go with a more convenient method? So instead of finding fy first and then applying, I assume that afterwards you will be applying Pythagoras theorem. So why don't we use this equation straight away? I mean, we studied this expression, fx equals to f cos theta. What do we have? Don't we have the value of fx? We do have, which in this case was 3 Newton. F, the vector itself, needs to be found out, so we gotta write it as it is. Then cos of the angle theta. Don't we have the value of the angle theta? We do have the value of angle theta. So we write it over here. So what is the vector f equal to? That equals to 3 divided by whatever the answer of cos theta is. Cos 30 is, which I assume is 0.867 something. Or you can just hit the fraction button, write 3 in the numerator, cos 30 in the denominator, and press equals to button. So this is a better and the faster way to find the overall vector when one of the component is given and the angle is also given. So if the angle is given, you can straight away use this expression. But if the angle is not given, either you can find the angle first and then you use the same one, or if you don't want to find the angle, you can straight away use the Pythagoras theorem. So then the next thing is, if we have a vector, let's say, which is oriented this way, let's call it vector f. Then the question is, in what directions can we resolve this vector into perpendicular components? So the thing is, it's not mandatory that you resolve the vector into one into x, one along x-axis and the other one along y-axis. No, there is no such obligation. All right, so I can say this is one of the component and this is the other one component, if this is the angle theta. But at the same time, that vector can be resolved in some other directions as well into perpendicular components. So for example, I can safely say that this is so let's say, yeah, this is one of the component along this direction. One of the component perpendicular component of this vector is along this direction, and then the other component has to be perpendicular to this one. So the other component of the vector, of the blue vector, the red ones are the components. So the other component has to be perpendicular to the red one. So probably in this direction. So if this is the angle theta, then this one would be fx, which equals to cos theta. And the other one, fy, which would equal to f sine theta. The rule of thumb is the most important thing. The component which is directly with the angle theta equals to vector times cos theta. The magnitude of the vector times cos theta. The one that is touching the vector. Sorry, the one that is touching the angle. So you see this component was directly with the angle. So this one equals to the magnitude of the vector f times cos theta. And the other one would subsequently be f sine theta. So here we have some practice questions. So what do we need to find? Okay, determine either by scale drawing or figure 1.1 or by calculation, determine the tension in the string. So the value of this vector needs to be found out. What you can do is, the easiest thing is, you'll realize that you can extend the same vector. Okay, just for your convenience, I'm going to extend this vector first. I can extend this one over here. This is still the vector. You can call it r. We have just reversed the direction, but the magnitude remains the same. And I'm going to extend the other one t. So I'm going to draw a parallel line in this direction. So I need to find the vector t. The vector t needs to be found out. So could you tell me how much this angle would be? And what do we call this one angle? 35 degrees. What do we call this one and this one? What do we call pair of these angles? Yes, vertically opposite angles. Exactly. So vertically opposite angles. Now, think about it this way. I need to find the value of tension. I need to find the magnitude of T. The direction is not important. I have drawn a vector in this direction which would be equivalent to T. In terms of magnitude, it would be same as T. And this one, since it is also in the same line or parallel to the vector r, it would be equal to magnitude of the vector r. So if you extend the vector backward, magnitude wise it would just be the same. Now what I'm going to do is I'm going to consider the black one, which is the vector of 25 Newton, as the main vector, and I can say that these red ones are the perpendicular components of the vector of 25 Newton. Let me repeat again. The vector that we have is the main vector that we have. Let's call it the vector f. That is 20. Basically, it's the weight of the block. This is 25 Newton. This is the main vector. And these two red arrows, just check their orientation. These two are perpendicular components of the vector 25 Newton. Now, the next big thing. What would this component, what would be the expression, mathematical expression for this component of the vector? Would it be 25 times cos of the angle, which is 35? Should it be 25 cos of the angle or 25 sine of the angle? What do you think? No, let me break it down. So the rule of thumb is, you can write it over here. So you see this angle, sorry, this component is touching the vector directly. This component is with the angle. This component is making the angle 35. So the one that is making the angle directly would be written with cos of the angle. So this one would be 25 times cos 35, and the other one would subsequently be 25 times sine 35. So the rule of thumb is the component making the angle could be any angle. Making the angle theta means could be any angle with the vector is the vector times cos of the angle. That's the rule of thumb. So can we say, if we need to find this value of tension, magnitude of tension, do we need to find 25 sine 35 or 25 cos 35? What do we need to find? So this is one of the methods. So we were given either by scale drawing or by calculation determine the tension. We could have done scale drawing, in which you have to convert the Newton into a certain scale. For example, 25 Newton can be labeled as 5 centimeters and 35 could be labeled as 7 centimeters. So you make a scale first. We're not going with the scale method. We do it already in O levels. We do plenty of questions of that. But here we'll be resolving the vectors into components.